Hi, and welcome to the fourth lesson in this series. In this video, we're going to look into more advanced tools for managing all of the extra axes that we have at our disposal with robotic machining. Obviously, the greatest strength of robotic machining is the freedom of movement that we have available. However, the question arises, how best to capitalise on and control this extended range of motion? Fortunately, there is a specific tool that's both powerful and easy to use that's built into ENCY. The axis mapping tool. Specifically, the axis mapping tool exists to be able to define dynamic axis management throughout the length of the toolpath. That's a pretty solid lump of jargon right there, so let's break down what it means. In the previous video, we defined an axial offset for the sixth axis of the robot to allow it to get close enough to the workpiece for it to be able to machine it successfully. Instead of the static rotation of the sixth axis we used before, we can use the axis mapping tool to now redefine this so it actively changes throughout the toolpath. So, to try this out, we're going to disable the previously created operation and start afresh. We create another 5D morph operation with the same surface and curve information. We're not going to change the turntable properties, so that can still move, nor will we change the offset of the arm this time. In the Setup tab, we can see that beneath the immediate axis controls there's the axes map. When we open this, we're presented with a new window. Looking along the top of the window, we can see that the sixth axis of the arm, any external axes, lean angles and lead angles are made available to us for direct control. We'll come back to the nature of this control in a second. Looking at the left-hand side of the new window, we can see that there are some configuration options, some collision map features, resolution and scale settings, a few buttons and safe distance settings. For now, we're mainly interested in the buttons and the collision map information. So our first step is to look at controlling the first turntable axis, or the E1 axis. So we click on the Axis E1 tab, then on Build Map. As we can now see, the main section of the window has been populated with colourful graphs. These colours represent the various constraints that are imposed upon the toolpath by a combination of factors, ranging from collisions between the robot and the workpiece, the intended movement exceeding the robot's physical reach, and singularities. A brief side note, singularities aren't quite as exciting as sci-fi would have us believe. In this context, it simply indicates that the maths that governs the robot's motion planning can't coherently resolve itself. This sounds a bit reductive, but the specifics are beyond the scope of what this video is intended to cover. So, to return to the issue at hand, if we click on the Build Graph button, we can now see that a green line that crosses from the left side of the map to the right has appeared. This represents the ideal path for the axis in question, so the whole of the toolpath can be achieved. If we click and drag from left to right, we can see that the x-axis of the map represents time across the duration of the toolpath, while the y-axis represents the rotation or tilt of the axis in question. It's important to note that if the green line cannot be generated, then it means that the current configuration makes it impossible to designate a safe toolpath. Now that we have our toolpath graph, we can click on Regenerate Toolpath, close the axis map window and then run the simulation. As we can see, the toolpath is definitely improved. It's a viable toolpath, but one that's based on not having changed the orientation of the sixth axis. So, we can return to the axis mapping window to further manipulate the toolpath. If we generate a map in the Axis A6 window, we can see that although there's a solid clear path all the way through, it's still possible to alter and control the behaviour of the axis in question. Clicking on Build Graph will give us a clear linear path, but this path can be altered by clicking directly on the generated graph line and moving the point you clicked on. Remember, the vertical axis governs the amount of rotation in the specified axis, and the horizontal axis is an expression of elapsed time. So if we were to push the graph line around to resemble a zigzag, or if you're feeling fancy, a rough sinusoid using the spline tool, we can then see how this changes the axial behaviour of the robot. If we click and hold the mouse, then pan across the toolpath, we can now see the direct effect that our graph manipulation has had. Aside from previewing the toolpath as an animation, we can also check the toolpath in a graph format as well. This is useful for making sure that there aren't any small, stuttery, repeated motions that can cause a robot problems. Now that we've previewed it, We can regenerate the toolpath and reset the simulation to see the full result of what's changed as a result of our imposed 6th axis control. All of this direct control can be applied to the previously listed axes, any external axes, and the 6th axis of the arm itself. The lean and lead angle tabs specifically control the tooltip angle when in contact with the workpiece. We'll cover these in more detail in a subsequent video. Now that we've made the changes we want to, and have simulated them to prove that the toolpath is good, we need to be able to export the program. It's not all that useful just sat on our computers after all. To do this, we return to the machining space and go to the Post-Process button in the top of the screen. In the window that's opened, we select the appropriate post-processor for our machine. Once we've done that, we click Run. We then get a preview of the final program, which is often useful for sanity checking purposes before we commit a robot to performing the task. This concludes the video, and this is the final video in this first series of tutorials. Beyond this point, there will be more detailed tutorials and in-depth discussions of specific features coming up in the future.